Hey y'all, I want to show you how to solve literal equations. So it's called literal equations, and basically all it means is you're going to get a math problem with no numbers. It's just going to have variables, right? That's it, or symbols. These are variables, And it's going to have operators. An operator is like a plus, minus, division, multiplication, equal sign. Those are called operators, right? So you're just going to get these guys and no numbers. So your goal is to solve them, right? And the directions are typically like in the question, right? So let me give you an example. Like here's an example here. See, here's how the directions are like in the question. It's a solve for Q. So we know we're going to isolate Q. So what do? I'm going to rewrite this because I guess I'm getting older and it's kind of hard to see. Right? Okay, so I have QP minus X equals Y, and I got to get this guy by itself. So where do I start? I'm going to do the inverse. I'm going to do the opposite to kind of reverse everything. And whatever I do to one side, I got to do to the other side of this little equal sign right here. Right? So I'm going to do plus X. What does that give me? Well, this gives me 0. And then this gives me Y plus X. If you're not sure, the thing you put underneath always goes right behind, right? So that's typically how it works. I'm going to bring this down, and it makes QP. Let's bring down this little negative sign too. We don't really need to, but do you see how this is all one problem? This is our new problem. Let's clean it up, and it becomes QP. We get rid of that. Equals Y plus X. Great. We're doing wonderfully. All right, so we cleaned up this left-hand side of the equal symbol. What do I do next? Well, maybe we can get rid of that P. It's being multiplied against Q, so we're going to do the opposite, which is division. Get rid of that. So it becomes Q equals Y plus X over P. That's my final answer, right? So it was just a bunch of alphabets. That's it. There was no numbers. And this is algebraic manipulation. You're just basically throwing things on the left hand or the right hand side. And you're just doing the inverse. So let's make a chart. Here's what you're getting. This is giving you something from the problem. And then here's what you're going to do if it gives you that. So if it gives you a plus, you're going to do minus. That's the inverse. If it gives you a minus, you're doing a plus. If it gives you multiplication, like the Q and the P right here were, you're going to do division. And if it gives you division or like a fraction, you are going to multiply. That's it, right? So we had Q P minus X equals Y. Right here, we turned it into a plus, right? And then over here, it was multiplication, so we did division. Remember how we went P like that? That's division. That's it. We just kind of do the opposite. Another thing I think would be useful is when you're dealing with fractions and when you have a fraction, you gotta multiply, right? And you're trying to get, let's do like a 7. Let's do 7 up here. Okay, so when you have a fraction and you have to get rid of the fraction and turn it into like a whole number, you have to get rid of the top, get rid of the bottom. The way you do it is you can only mess with the bottom number. So if I wanted to get rid of that 2, I can do 2 over 1, right? See how it disappears? And it becomes 7. Well, the reason the 2 would go over somewhere else because I would have like this whole problem like this with an equal sign and it goes in the opposite side. So it became a 7. That's chill. We could do that. But say it's said in the math problem, get rid of that 7, right? Let's pretend the math problem said, hey, isolate the 7. Okay, what I straight up can't do is just do like 1 over 7. That's like illegal in math. So you have to mess with the bottom first. So what would I do here if it told me to get rid of the 7? You move the 2 first. You move it over to the other side of that equal sign. And then and then you start messing with the 7, right? If that makes sense. So sometimes you got to take the thing you're messing with and throw it over on the other side and then move it back later on. So it gets a little bit tricky. And I'll show you what that means. Okay, here's another problem. It's saying solve for y. So let's rewrite it here. Wait, that's a y. So we have y over x equals c. And we're solving for y. So we're getting rid of this top guy right here. That's our goal. Oh, we're not getting rid of it. We're keeping him. We're getting rid of everything else. So what do I do? Let's see. Well, I can't really do anything with c. I mean, it's kind of useless because my goal is to take everything and put it on the other side of the equal symbol. That's what my objective is here. When it says solve for y, it means get it by itself. So it's going to live alone and everyone else is going to be roommates on the other side of town, right? So the other side of town is right here. Let's see, what do I do? Well, I can multiply x over 1. That way we can get rid of the x over here. Whatever I do to the left side, I gotta do to the other side of town, right? If you're mowing a lawn, you gotta go all the way down. You gotta go to the front yard and the backyard. So you gotta treat it the same, right? So this disappears, and I get y equals c x over 1. Is that my final answer? Well, yeah, technically, but when you get a fraction with a -1 underneath it, it's understood that that 1 disappears because they all technically have an invisible 1 underneath. And I mean, I guess you could turn this in as an answer with all the -1s, but there's like a way of presenting your work in a like more sophisticated, polished way. So this would be the final answer because the 1 in the bottom, it's understood. So this, in fact, is the final answer. Now, here's the thing. Technically, yeah, this is also right. And technically, yeah, this is also right. But this is really what you want. This is the more sophisticated, cleaned version. Let's try more stuff. Okay, here we go. Here's something that is interesting. So this is called a proportion. A proportion is when you have two fractions with an equal sign, right? And the way it's read, it would be called b is to x as p is to q. That's how you read this. I mean, that's not really that important, but I just wanted you to know that. So we're going to solve for x. That means we're getting this guy by itself. Let's go ahead and rewrite it, just for funsies, because we've been doing that. That's p and q. P and q kind of look similar, so keep in mind the directionality. That way we don't confuse them. Because you think it's no big deal, like, you know, the difference between P and Q, but when you're just sitting there for hours doing math problems, they all start to look the same. Okay, cool. Let's see. So I want to get rid of the B up here. But remember, I can't do that. That's illegal, right? And we practice math lawfully. We are law-abiding citizens in the world of mathematics. So when you have a numerator, let's do this symbol to represent numerator. Let's represent this symbol for denominator, the bottom part. When it's asking you to get rid of stuff and isolate stuff, let's say you have to isolate this right here, like as the question states. I'm not allowed to just do like one of these. I can't just put like the numerator here and then just cross things out. That's illegal. I can't just rip off the top. I can only take off the bottom, right? So think of it like think of it like a cup of water, right? And it's full. It's really full and has like a really wide mouth and it's like really huge. Let's say it's like a foot wide. It's like super big. It's like a foot wide. So it's like super long. 1 foot. When you carry this glass, you're going to carry it from the bottom, right? It wouldn't be smart to carry it from the top. If you carry it from the top, it's going to tilt, it's going to be weird and heavy, and you're going to drop it. So you don't ever carry a giant, novelty-sized, crazy cup from the top. You always carry it from the bottom, right? So think about that when you're messing with these fractions. is that you can only take away from the bottom. You cannot mess with it from the top, if that makes sense. So think about the crazy wacky glass example, I suppose. So what do I do? Because I got to get x by itself, and you're telling me that I can't mess with the top number? Like I straight up can't just like do one of these? That's not allowed? And yeah, straight up it's not allowed. Okay, so what do I do? Because like you're telling me it's not allowed, so what's the next thing I do? Well, it's possible for us to move over the thing that we're trying to isolate and move it back later where we need it to be. So we can do that, right? Let's go there. It's just one extra step. And we have to do this step because everything else is illegal and we are law-abiding mathematical citizens. So this gets crossed out and it becomes b by itself. And then we have px over q with that invisible 1, right? So look, man, we're making progress. And I know it feels like we're not because now x is like hanging out with like 200 people and we need it by itself. But it's going to get there. It's going to live alone. Okay, right now it's just partying with some people. So let's see. Or variables. Okay, so it's hanging out with these variables. What do I do next? Because I got to get it by itself. Well, we can get that q by itself because that's the bottom of the cup, right? We can't mess with the top. I can't rip that p off. I can't rip the x off. I can only mess with the q because my water cup is really, really heavy. I can only grab it from the bottom. Let's do one of these. It's division, so we're going to multiply q over 1. These disappear. What does it leave me with? It leaves me with qb equals px. Wonderful. This is coming together beautifully. So what do I got left? Well, we're isolating x. Let's divide by p because we are multiplying. Originally, it told us that p is being multiplied against x. So what we're going to do is we're going to divide to get rid of it. Those disappear. And what does that leave me with? It leaves me with qb over p equals x. This is the final answer. Well, that's exciting. It's quite a trip. We can also clean it up a little bit if you wanted. It's not really necessary, but it's the exact same thing. I just flipped it a little bit. And you're allowed to do this. You're allowed to just flip the whole thing. I didn't flip the actual fraction. I just moved this guy to the left and I moved this guy to the right. And we can do that because an equal sign represents proportionality. It's just to put the x on the left-hand side. You don't have to. I mean, these are both chill. You're good. Let's do a couple of more. Problemos. Let's see. My screen froze. Okay, great. I got the next problem here. We're going to isolate this problem right here. Or variable, rather. Okay, so let's see. That's the letter G. It looks kind of like a 9, but it's a letter G. Guess I didn't see that. Okay, so I have a G. I have an M. And then I have a K. And I got a C. Okay, how exciting. Okay, so what do we do first? Well, I have to get rid of the C, right? Let's see. We can't, well, I mean, I guess I have to get rid of the C first because, again, I can't get rid of the K. I can't just rip the K off and throw it on the other side because my cup, every time you look at fractions, think about that cup. If I want to get rid of stuff and I want to start breaking my fraction apart, I can only break it from the bottom. I cannot break it from the top. So I have to hold it from the bottom and move it over to the other side of that equal sign. I cannot grab my cup from the top and move it over to the equal sign. It is impossible. My cup will spill because my cup is shaped wacky. It's looking like this, and it's like a whole foot wide, and it's just comically overflowing. Okay? So I can't grab it from the top. It's like impossible, man. I don't got the wrist strength. But I can grab it from the bottom because I can help with that force, it's just going to be beautiful. You can take it over there. This is illegal. Okay, so how do I do that? I'm going to do C over 1. C over 1. Those disappear. And I know it feels counterproductive because my whole goal is to isolate C. So if I'm supposed to isolate C, why am I touching it and moving it over? I shouldn't even be touching it. Sometimes the math takes you there, right? But we can always move it back. This is lawful what we're doing. Totally legal activity, right? So now C is partying with all its variable buddies, and he's going to come back home in a second. So what do I do next? Well, I can't rip off anything from the top. So we know right away the only thing I can do is mess with M. I'm not messing with K because my goal is to get C by itself. So there's no reason for me to touch K. I'm not allowed to touch the C or the G at the top of that fraction. The only thing left is M, and it's being divided. So I know I'm going to multiply, right? In your textbooks, when it's multiplying, when you see that division, it's just going to look like this. That's what it looks like, right? So then that disappears and that disappears. It's the same thing as what I just drew, where it looked like this. And I did one of these numbers. It's the exact same thing. So then I am left with CG equals KM. Perfect. I'm almost done. Because now I have to get C by itself. K and M, I don't need to touch them. There's no reason. I'm totally cool to get rid of G. Cool. He's going to the other side. What am I left with? I'm left with C equals Km over G. C is the answer because we're solving, well, I mean, C is what we're solving for, and then the answer itself is right here. All right, perfect. This is going swimmingly. Let's do another example. Let's see. So, oh, this is kind of like a formula. That's exciting. Let's see. So we are solving this whole entire thing is a formula. It's a kinetic energy formula. So you're going to see it in like physics and stuff. We're solving for M. That means I got to get this guy by itself. And we got to include that K in there, right? So I have K equals half mv squared, right? And if you're not sure, technically, if you wanted to rewrite this in a way that's more like balanced, this would have an invisible 1. Then this would be mv squared 1. Every time you see like letters or numbers or something dangling, like right here dangling, they actually move to the top and there's a 1 here. This is not quite a literal equation because of that half, but I wanted something with like a fraction, and I wanted visually in this direction so you can see how to solve it if there was like a C and like a Z or something, I don't know, whatever. Cool. So we have it all set up, and I'm supposed to isolate M. And of course our rules are when you get that big giant cup, you can only put your hands in the bottom of the cup, not the top. So we can't change anything in the top. So we can only change the bottom, right? So what does that look like? Well, it's going to be a 2 over 1, right? The only thing I can mess with is this guy. And whatever I do to one side, I got to do to the other side, right? So that crosses out, that crosses out. It gives me 2k equals mv squared, right? So let's see, what do I do now? Because I got that v squared and I got that m. Well, you can actually just do v squared. You don't have to get elaborate, right? We get rid of that. So my final answer is 2k v squared equals m. That's it. That's my answer, right? Literal equations, all you're doing is training yourself to move stuff around. You don't necessarily have to do any math. Here's another one. This one has a number in it. And so does this one. I don't know how this one got into my collection. We can skip it, but let's go ahead and try to solve it. Why not? Right? This is not a literal equation. This is just an equation, right? We're just messing with equations now for some reason. Okay, so how do I do this problem? This is what we're doing. It's this whole thing right here. And we're solving for p, which is right there. Well, we're going to distribute. We're going to distribute this, and we're going to distribute that. Right? So I have d equals, this is not a literal equation. You can skip this if you want. We're just going to do this for funsies. 11 over 5. I'm going to put that p at the very top. And then I have the negative symbol, which is going to be 11 times 15 over 5, which gives me d equals 11p over 5 minus 165 over 5. Great. This we can reduce, so it or simplify. 11p5. That's 165. 27. Is it 27? Let me see. Let me get my calculator. 65 divided by 5. No, it's 33. I was kind of sort of close, maybe not really. Okay. I was thinking 27. Okay, sweet. So then that drops. We have a whole number. Okay. Let's see. What do I do now? Because I have to get p by itself. Let's see. Getting p by itself, we're going to go ahead and add 33 to both sides. So it gives me d equals, oh, it's not d equals, it's d plus 33. Right here, we move it to the back. Equals 11p5. Great, we have another fraction, and if we remember the rules, the cup of water, you can only grab it from the bottom. So I cannot just rip that p off and throw everything over and be good to go. I gotta get rid of that 5 first. So it becomes 5 over 1. 5 over 1. So it becomes 5d plus 33 equals 11p. Oh, this is exciting. We're getting somewhere. Okay, what do I do now? I gotta distribute. Technically, you can leave it, but 5 times 33 is 165, right? We got it from here. $11p. All I did is just distribute the 5. Okay, and now I can get rid of the 11. So it leaves me with 5d over 11. These right here, I think we can, let me see, I have 165 divided by 11. Yeah, it gives me 15. Plus 15 equals p. This is my final answer. That's a bummer it's not a literal equation. Great. Let's try this one. This is a literal equation. Hooray. I guess we were unlawful because we had non-literal equations. Look, guys, this whole time we were trying to follow the math laws, and then we broke them. We're criminals. Okay, so this is a proportion again, right? Every time there's two fractions with a equal sign. Okay, let's try to do that. We got to solve for t. Let's rewrite it. S t equals r q. And if we remember our crazy heavy water glass, I could only grab it from the bottom. I can't grab it from the top. That's not allowed. No. Okay. So I can only grab it from the bottom. That means I can't just rip the S off and throw it on the other side and say, hey man, I'm done. We can't do it. So we gotta get rid of the t. Even though we're solving for t, we're gonna get rid of the t. So I have S equals RTQ. And then what do I do next? There's no reason for me to touch S because it's not useful. I can't touch anything in the top because it's forbidden. all I can do is mess with Q. I have QS equals RT. Okay, sweet. We're getting so close. What do I do now? Well, I have R and T, and then I have Q and S. There's no reason for me to touch Q and S, so I'll leave that alone. R is being multiplied against T. They're being multiplied. So what's the opposite? What's the inverse? Division. So I'm going to get rid of the R. We're getting rid of the R, and that leaves me with QS over R equals T. This is the answer, y'all. Hooray. All right, that went splendidly. It wasn't too hard. It wasn't too easy, but it was pretty good. And then we learned about how to take fractions and how to mess with them, how to manipulate them in a way that's mathematically lawful. Although we did have a couple of non-literal equations slip through the cracks, which was a super bummer, but I guess sometimes that happens. And I hope this video helped you guys. And we do have stickers in our little sticker shop if you want to go take a look. Okay, thank you. Goodbye.